install capacity. The government is currently trying to reduce the use of coal by not planning the new construction of coal power plant and looking the alternative to reduce the use of coal in the power plant. In other side, we know that we have several environmental problems, such as silting up reservoir or lakes due to the growth ICoGEE crassipes or water hyacinth. And then we know that we have a problem of the generation of urban waste that still have a problem with the landfill management. These two materials, ICoGEE crassipes and municipal waste, can be utilized or convert to the RDF to substitute the use of coal in power plant, but it's partially, not fully. It's only around 5%. This year, the government has issued the national standard that regulates the biomass RDF specification that used in power plant. And this standard regulates three quality of RDF that based on the type of the combustion technology in power plant. As we know that the combustion method in power plant is divided into three types: fixed bed combustion, pulverized coal combustion, and fluidized bed combustion. But the standard also include the old technology, namely is stoker. This technology needs a special requirement. The location of ICoGEE crassipe sampling is in Tondano Lake in North Sulawesi, and we also take a sample in Saguling Reservoir in West Java as a comparison. Our research center has also analyzed the characteristic of biomass from municipal waste in Sumompo in 2018. Sumompo landfill, we choose Sumompo landfill that assume that this landfill have a similar characteristic with the condition in Minahasa or the area of Tondano. The composition analysis, we refer to the best practical application of national standard 3964, 1994, and the analysis of the characteristic refers to the ISTM, and the result will compare with the parameter is national standard for RDF. We can see the parameter in this standard that will get used in the coal power plant. This picture shows that the composition of municipal waste in the Sumompo landfill still dominate by 62% of organic waste, follow the plastic 15%, paper 10%, clothes or textile 2%, glass 1%, and others. This composition is not different from the composition waste that we have studied in several landfill in Indonesia, where the percentage of organic waste is about 54 until 62%. So based on this data, they have 87% potential waste for RDF come from the combustible waste such as organic, plastic, and paper. In the right, we see the coverage of Eichhornia crassipes in Lake Tondano is around 4% or 181 hectares of the total lake area, around 4,000 hectares. Physically, the Eichhornia crassipes in Lake Tondano have a larger size than in Sangguling. The density of Eichhornia crassipes in Tondano is 25 kilogram per square meter. So that the wet weight of Eichhornia crassipe in Lake Tondano is around 45,000 tons. Now we can see from the table that the water content in Eichhornia crassipes and municipal waste is still relatively high.
Yes. Your time is still 1 minute to go.
Okay. Eichhornia crassipes has moisture about 90%, and municipal waste is around 60%. The high moisture will cause the low calorific value of biomass. Nah, Amurang's CPP have doing co-firing tests for biomass and coal. Now the coal substitution at Amurang CPP reached 5%. Based on the characteristic of coal in Amurang CPP, we can calculate the need of biomass from Eichhornia crassipes is only can fulfill for 62 days at the moisture content of 10% and the calorific value close to the coal. So we need the other alternative to maintain the sustainability of the supply of material, and we use the municipal solid waste. And from our analysis, we can use the fresh waste or combustible waste to substitute the lake of to fulfill the lake of the Eichhornia crassipes need in the coal power plant. So we have to come to conclusion that Eichhornia crassipes biomass and municipal waste have a high moisture, and so it needed to initial processing to meet the calorific value with the coal in use in power plant. And then the RDF biomass of Eichhornia crassipe can be used as raw material for co-firing, but only supply for 62 days. The use of municipal waste can be covered the lack of Eichhornia crassipes to ensure the sustainability of the supply. And it comes from the combustible waste or fresh or mixed waste. That's all for my presentation. Thank you. I'll back to the moderator.
Okay, thank you very much, sir, for your presentation. It's a really nice presentations. Okay, for all participants in this room, any questions for this presenter? If you have any questions, you can send us by chat room or just raise your hand. Anyone? Okay, if nobody here that want to ask Mr. Ragil and Mr. Adolf, so I will ask you about, oh, okay, we have one participant that raised hand. We have Mr. Muhammad Darwis. Please
Yes.
open your mic, sir.
Okay, thank you, moderator. Mr. Adolf, thank you about your presentation is good because it's about the sorry about the signal about the biomassa. It's good. I want to ask how many percent about the application of the biomassa of Indonesia, Mr. Adolf. Thanks.
Okay, Mr. Adolf, please answer the question from Mr. Muhammad Darwis.
Okay,
Yeah, thank you.
Mr. Darwis, the current condition of the use of biomass in Indonesia, based on the data 2020, in my paper is only 2%, 2.5%, or about the 1,700 megawatt. Jadi it's now is still very low the application of the biomass in energy sector. Maybe that's the answer.
Okay, because Mr. Muhammad Darwis has give a question to Mr. Adolf, so we can next to the next presenter. I will call Mr. Putra Pratama. Are you here?
Sorry, wait a few minutes, moderator.
Okay,
Okay.
I will go to the next presenter.
Okay. Thanks.
Okay, for the next presenter, we have a Miss or Mrs. Ikhlas Kita. Are you here? For ID paper 28. Okay, please give your presentation. For your reminder, you have 10 minutes to give a presentation. Mrs. Rizkawati, we can not hear your sound, your voice. Are you start already? Please make sure your mic is open. No, we can hear your voice. You have some technical problems. So I will go to the next presenter and I call you later. Okay? Okay, I will call the next presenter. We have Mr. Priyoko Prayatno Adi. Mr. Priyoko will give presentation using the video.
I think it's still mute. I can hear your voice.
Sorry, me too. I cannot hear.
to 225 degrees Celsius. The design of the PLTGL linkage has a maximum capacity at a sea wave height of 0.25 meters. This has an impact when entering data into the simulation in the motion study data using scaled data, which is assumed to be the same as data from Geospatial Information Agency. So the result and the discussion of our research is that the design of the PLTGL linkage system was agreed upon the PLTGL design team and made using SolidWorks applications. The dimensions of the PLTGL design are still in the estimation stage or only assumptions and do not take into account the mechanics of the material strength and the working forces. The movement mechanisms of this float level moves up and down according to the sinusoid of the wave. But in this study, it is driven by using CAM system. This level is connected to the linkage arm mechanism, which is the main component in this design. The movement of the scissors arm will move the connection arm, and then this connection arm will pull and push the iron plate connection that has been connected into the rack gear, which later this mechanism iron plate connection that has been connected. This mechanism will make the rack move back and forth and move pinion gear. The last mechanisms is the shaft mechanisms. The back and forward movement of the rack gear is converted into one direction rotation with the help of ratchet system mounted on the shaft after the pinion gear. This causes the shaft to only rotate in one direction and will eventually rotate a dynamo that has not yet been designed, but it is expected to use a belt and pulley transmission. So the motion study, the simulations in SolidWorks use a scale of 20% of the ocean wave size obtained from DIG. This is because the designs made have not taken into account the result of the realization of the sea wave heights, while the design that have been made have a limit of being able to rise to 0.25 meters. This situation causes the ocean wave data to be adjusted to the scale obtained by dividing the lowest wave divided by the highest, which is 20%. Furthermore, the highest value is 0.20 or the 245 meter, and the lowest value is 0.057 meters. The procedure for getting rotation per minute in the SolidWorks application: first, the sea wave height data is converted to the frequency of frequency which is entered into the SolidWorks application, and then the angular speed will appear, which is then converted into rotation per minute after converting the units of degree per second to rad per second. About the printing modeling, the linkage system PLTGL prototype model is made based on a design that has been simulated through the SolidWorks application. You can see at the model in here. The model was made with the help of CR10 V3 type 3D printing machine. The parameters applied to this machine are print temperature of 210 degrees Celsius with a print speed of 60 millimeter per second and a layer height of about 0.3 millimeters. The variations in the completion time of the 11 parts of the PLTGL model is from 11 minutes to 2 hours and 55 minutes. So the conclusion of this research is that the linkage of the PLTGL design has been produced with variations assumptions that this design only looks from the point of view of the movement that converts the up and down motion of the buoy due to the ocean waves to the back and forth motion of the gear rod that rotates the shaft to generate electrical power in the dynamo. Secondly, the simulations in the SolidWorks application have helped designers to visually better see the movement in question and even known the final rotation of the driven shaft with certain limitations, such as not involving the mechanical forces that occurs in the PLDGL systems. Lastly, a 3D model is created to be able to see from the point of view the PLDGL movement in 3 dimensions. This helps designers to decide important things to do in the future for this leakage type PLDGL product. Thank you very much and see you later.
Okay, because Mr. Priyoko not here, so if you have any questions, you can send by email to Mr. Priyoko, and I will move to the next presenter. We have Mr. I Putu Angga Kristiawan with ID paper 33. Are you here?
Yes, I'm here.
Okay, please give your presentations.
Okay, first, let me check my presentation first. Sorry, share screen first. Can you see my presentation? Is it already in presentation mode?
Yes.
Okay. Thank you for the time that give it to me for the Miss Moderator. In the third international conference on green energy and environment, I will present about our work, which is the air quality index based on measurement of mobile air quality monitoring station at the waste to energy incineration plant PLTSA Bantar Gebang. Me myself is Putu Angga Kristiawan. You can call me Angga or Kristiawan. And we are from Center of Technology for the Environment, the Agency for the Assessment and Application of Technology, BPPT, or recently it's changed to the National Research and Innovation Agency, or BRIN. In my presentation, first I would like to introduce why we do this kind of research, and also I will describe about the methods that we use, the mobile monitoring that we use, the measurement and data processing, and also how we can determine the air pollution index. And for the result, I will show the mobile monitoring result, the calculation of air pollution standard index, and also we will discuss some of them by using the result. Why we do this? It's first because, as maybe some of you or a lot of you already know, that in 2018 until 2019, BPPT with collaboration with Jakarta built a pilot project for the waste to energy incineration plant in Bantar Gebang. This is the schematic diagram of the power plant, and the capacity of this plant is around 100 tons per day, and it already fully operated 24 hours a day from 2020. So until now, in 2021, we still do the operation and maintenance for the PLTSA Bantar Gebang. First, as you can see, the PLTSA Bantar Gebang consists of several mine part. The first one is the waste bunker, which can store the waste, the municipal solid waste, inside the bunker, and inside it there is also a line for leachate or the wastewater, and we process the wastewater before we release to the environment by using our wastewater treatment plant. And after the waste is ready as a fuel to the furnace, we put it into the furnace by using a crane, and they will go through the incinerator. The incinerator that we use in PLTSA Bantar Gebang, which is the grade incinerator as the below picture show, and inside the grade, the combustion will be occur. The heat that we did that produced from the waste combustion, we will take not all of them, but some of them, and we use it to make a steam, the high pressure and also high pressure and high temperature steam, to turning the turbine generator that can produce approximately 700 kilowatt power per day. The harmful gases like the dioxin, furan, and also the oxide gases, the odors gases. And after that, we filtered it by using our back filter system before releasing to the stack. And as the result of air pollution control, we generate some fly ash, and based on the regulation, we already managed to use the fly ash as a puffing block, and it is utilized inside the TPST Bantar Gebang or some area around the TPST Bantar Gebang. For the air pollution control system, we measured it periodically using our gas analyzer, and also we do the monitoring by others laboratory monitoring session. And of course, we also measure the ambient air quality monitoring using our mobile lab monitoring. But the problem with the monitoring that already done, they don't show it is harmful or not to the human health. So we need to know that the gas released to the environment is not harmful. How can we know it? We can know it by using the air pollution index based on Indonesian regulation. Based on the newest regulation, the air pollution index could be measured by using a monitoring station, either it's fixed or mobile. And in the Peltesa Bantar Gebang, we only have mobile monitoring station. There's no also a fixed monitoring station around, and so we will use the mobile monitoring station to first. In this work, we would like to monitoring first the ambient air quality, especially the concentration of the gases. And also we will determine the air pollution index so we can evaluate the impact to the ambient air quality. This is the method that we use. The mobile monitoring the mobile monitoring, it consists of a series of ambient air quality monitoring like CO, SO2, NO2, O3, and also equipped with the particulate matter monitoring. Besides that, we also have the meteorology monitoring system inside, and the data that we can get for this work, we use the position near the stack, and the data itself we can extract from the logger and within interval of 1 minute from each data. And after we got the data, we will determine the air pollutants index using the index calculation, and after that we can state that is in health or not healthy to the human health. This is the result. First, I would like to show you the mobile monitoring result. Several gases that we monitored, as you can see inside, we do 24 hours measurement. And for the first, I would like to say that the maximum CO, concentration CO in the ambient that we monitor can reach around 2,500 microgram per meter cubic. And it's its highest concentration is CO concentration in the ambient air. It's more than SO2, O3, and NO2. The SO2, O3, and NO2, the nitrogen, it's below 500 microgram per meter cubic. And let's see the particulate matter. In the particulate matters, first they have some trend in our measurement. It's similar between them. The particulate matter will be rises until 8 a.m. and go down from 12 until 13 p.m. and also rises again until 17 p.m. And both of the particulate matters have a value below 120 microgram per meter cubic. the calculation of standard air pollution standard index show us that most of them are a good in a good quality of in a good quality, and only particulate matters 2.5 that in category that in moderate category. First, if we see the monitoring result, it's the operational hours not only of PLTS Bantar Gebang, it's very related to the monitoring result. The all concentration look like follow the operational hours, which is the morning of morning. There's a lot of operational hours, like the heavy duty machine from the others side inside the TPS Bantar Gebang also activated in the morning and afternoon. So it's also contributed to the concentration measure, and especially for the high particulate matter of 2.5. It's because the measurement location or the monitoring location that when we do the monitoring, it's very near to the fly ash silo.
Sorry,
And
sir.
as we know, the fly ash.
Sorry, sir, for your
it's very
information.
small.
Your time's still 1 minute to go.
Yeah, I will finish now. As you can see, the category of index say it's still acceptable to the activity. So actually, that's all for my presentation, and thank you for attention. Yeah, thank you for the attention, and I will give it to moderator.
Okay, thank you very much for your nice presentations. And we have one person that raised hand. We have Mr. Ragil. Please, Mr. Ragil, open your mic.
Okay, thank you for moderator. I have two questions for Mr. Angga. The first is, as we know that the main issue of the municipal waste incineration is dioxin and furan, but in your presentation it's not show the dioxin furan. Please give the explanation about that, and it's related how the temperature of boiler. I have catch the info. And the second question is about the particulate matter. As you present that it's reach more than 100 milligram per meter cubic. All right. As I know that the limit of the particulate matter is just 100, and it's taken by ambient. How about at the chimney? It's maybe higher than ambient. It's maybe exceed the limit. Maybe you can explain about that. Thank you.
Okay, thank you very much, Mr. Ragil, for your questions. Now, Mr. Angga, please answer the questions.
Okay, thank you, Mr. Ragil, for the question. Yes, as you can see, it's true. The main issue of municipal solid waste incinerator is the dioxin and furan. But first, to minimize the dioxin and furan, there is several processes that we need to make sure inside it. First is the combustion of the waste. The combustion of the waste should be not below 800 degrees Celsius inside the great incinerator or the combustion chamber. In our facility, you can also come to us, come to PLTS Bantar Gebang to see it clearly. In our facility, the great incinerator can achieve about 1,000 degrees Celsius, and in the combustion chamber in upper the grade, we also manage it to have the temperature around 800 degrees Celsius, and sometimes it can be 850 degrees Celsius. And after that, after the heat was taken by the heat recovery steam generator system and so on, the flue gas itself needs to be cared by the air pollution control. the air pollution control, we can use this dry scrubber like we use in Pltsa Bantar Gebang to make sure that no dioxin furan is released. Okay, the third one is the monitoring system. In the regulation for the waste to energy incineration, uh, waste to energy based on thermal technologies, the minimum of need for the continuous monitoring system or CHAMS is for more than 2 megawatt electricity produced. In our facility, we only produce 700 megawatt electricity. So now in Pltsa Bantar Gebang, we do not use continuous emission monitoring system or CHAMS. But but every years we also do the stock emission monitoring by others laboratory, like I said in the
We have some technical problem from Mr. Angga, I think. Okay. We wait a minute. Okay, I think it's enough. If Mr. Ragil want to know more, Mr. Ragil can reach Mr. Angga directly, I think, outside this room. Okay, I will move to the next presenter. We have Mrs. Fajar Indah Puspitasari. Mrs. Fajar will present his research using the video.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Fajar Indah Puspitasari, and I will to present our research article with the title Distillation Absorption of Bioethanol Using Natural Kaolin. Let we start from introduction. Fossil fuels consumption contribute to global warming. Is one of the biggest impact of using fossil fuel is global warming. This strengthens the government reason for developing alternative energy resources. Bioethanol has been known as one of the alternative energy resources to replace petroleum. Bioethanol can be produced from various raw materials which contain starch and glucose. Future refining to meet fuel-grade ethanol is required. Distillation adsorption method using clay-based material was developed to solve this problem. Distillation most commonly used in bioethanol purification is less optimum. So distillation adsorption using natural kaolin is a solution for meet the fuel grade ethanol. This is the material and method we use in this research. The material is cherry fruit and pineapple purines as a raw material to make bioethanol from Bangka, Indonesia, and then sulfuric acid, sodium hydroxide, distilled water, Saccharomyces cerevisiae, standard ethanol, and natural kaolin from Rawang District, Bangka, Indonesia. Equipment and instrumentation. The instrumentation used for analysis is X-ray diffraction and Fourier transform infrared for characterized kaolin, and gas chromatography GC for determine the bioethanol content. This is the basic concept of ethanol production, the raw material, and then pretreatment, and then hydrolysis process, and then fermentation, and then we get some bioethanol with uh, with mix and water. Figure 2 is the raw material in bioethanol production are cherry fruit and pineapple peels. Preparation and activation of natural kaolin. We use natural kaolin from this Merawang district, Bangka, Indonesia. Natural kaolin is cleaned by washing to remove impurities, and then chemical activated by H2OSO4. The activation process was carried by stirring the kaolin for 6 hours, and then solution was allowed to stand for 24 hours. After purification, we get some kaolin activated, and then samples stored in a desiccator and characterized by using SRD and FTIR to determine the crystallinity and functional groups. Effect of kaolin mesh on bioethanol purification process. We get some gram of activated kaolin, 1, 2, 3, 4, and 5 grams, and add to distillation flask and mix with 30 of ethanol. The absorption distillation process at 78 until 80 for 2 hours. The resulting distillate was collected in a distillate flask and purified bioethanol, then measured using the gas chromatography. Physical properties of bioethanol. Water are used for reference fluid in the measurement of density and viscosity bioethanol. Result and discussion. This reaction is bioethanol production. Reaction 1 is in a hydrolysis process. Sucrose and water then interface to glucose and fructose. Glucose or fructose in fermentation reaction with diamines, resulting bioethanol and carbon dioxide. And then process is activation of natural kaolin and adsorbate. The results show a reaction for activating natural kaolin. Figure 2 show the X-ray diffractogram of kaolin before activation and after activation. And figure 3 show the activated kaolin spectrum of Fourier transform infrared. From the data, we get that the position of the peak correspond to standard GCPDS, 3-number GCPDS, and in the FTIR, kaolin show OH vibration in some wave number, and ALOH vibration are hydroxyl group bond to octahedral Al atom and the surface between the silicate layers, and the wave number show the stretching vibration of SEO. Okay, this is the distillation absorption by kaolin addition. Figure 4 show the effect of distillation time on the bioethanol content, and figure 5 show effect on kaolin mesh on bioethanol content. From the data, we get the 28.1% is the ethanol content optimum from the distillation time variation, and 25.25 is the optimum ethanol content in the effect of kaolin mesh on the bioethanol process. According to work, the increase in ethanol content is caused by the ease of which the ethanol molecule evaporate, and the evaporation rate was caused by the ethanol molecule being twice fast as water molecule. This caused the longer the distillation absorption time, the lower ethanol produced. And in the effect of kaolin mesh, the highest ethanol content is distillation absorption with 5 gram kaolin addition. Ethanol content decreased due to several factors such as heating temperature, absorbent and pressure during the distillation process. The temperature must be kept constant in 78 until 19 Celsius so that the heat generated is able to maintain the stream velocity of the mixture that take place during distillation. Absorption mechanism occur because the framework structure of kaolin contains vacant space and it's occupied by cation and free water molecule allowing ion exchange. This absorption usually occurs on solid surfaces that are rich hydroxyl group OH hydroxyl. Bioethanol purification occurs physically because is influenced by the porosity of kaolin. The greater of cross-sectional area of kaolin and the absorption of kaolin to water molecule in ethanol solution. After obtaining optimum purification, kaolin mesh and optimum contact time, then ethanol, the highest content, 28.33%, test for the physical properties. The resulting R density is 0.81 gram per centimeter cubic and viscosity 1.88 CPS. This is the conclusion from our research. Except the calculation of kaolin show the kaolinative leptogram peak at 2 theta, blah blah blah, and the FDR results show absorption of OH-Al, OH and SeO-Al. The absorption is a functional group is kaolinate compound. Number 2, the contact time of kaolin bioethanol and distillation process was optimum for 1 hour with concentration 29.13%, and optimum variation kaolinate mass in the absorption distillation process was obtained in 5 gram with ethanol content 25.25%. Physical characteristic of bioethanol, density of bioethanol and the viscosity of bioethanol was mentioned. Okay, we gratefully acknowledge the funding from Universitas Bangka Belitung, RKKLFT, for publication of this paper. This research funded by Universitas Bangka Belitung, and thank you to LPPM for providing funding assistance in the 2021 University Level Research Program. Thank you also to the Bangka Belitung University for supporting each of the PDTU research team. Thank you.
Okay, because of Mrs. Fajar not here, so if you have any questions, just send an email to Mrs. Fajar. Okay, I will move to the next presenter. We have Mr. Muhammad Darwis. Are you here?
Yes, moderator.
Okay, please give your presentation.
Okay, thank you. Okay, Bismillahirrahmanirrahim. Thank you to moderator. I would like to presentation about my study. Sorry, I will presentation about the study of power flow in electrical system using ILM, or the name of extreme learning machine. I come from the Hasanuddin University, South Sulawesi. The first is about the introduction. About the electrical is the need, the special of Indonesia and South Sulawesi is very increased in many problem for demand of the power flow. So it's we have to analysis about the method. The method is the first one, power flow calculation method. They are four components we are the study to determine magnitude of the voltage and voltage angle or voltage vector, and then active power and reactive power, about the power losses. The second is about we have learning about the here about ELM and INN. We compare. What about the LM? Learning machine. We use the method is neural network with a single hidden layer. They are the name of is LVNS. And about the INN, artificial neural network, is a small processing unit or processes resembles as neural network system in human. The name is neurons. About the related works I use about the learning about is Mr. Gunadi, and the problem about the voltage instability, and I use the method testing is EEE 14 bus as I'm focused about that. And the next slide is the method. There are four use the method. Step one, our input data, and then input data use the active power and reactive power, and then created ALM, the process method, and then the third is we meet recur a validation process and carried out, and four is output various are voltage and phase angle. So it two input about the active power and reactive power. The output is voltage, magnitude voltage, and phase angle. You can use the process about the process. Yeah, you can compare about that. About the training LM, use the determinant with the weight height or W, IBS randomly, and then calculate about the matrix, and then calculation more the Penrose generates inverse matrix, and then calculation the output weight matrix of the hidden layer, and the name is SLVNS. Yeah. What about the result about the site here about the calculate result of the ELM and the side of right is about the INN. The process testing is carried out use the two methods, namely extreme learning machine, algorithm, and genetic algorithm. They says the result of the obstinate we are entering the same of they are named number of neurons is just 5 and number of hidden layer 1 and the number of input 2 number of output is 2. So the software is process use the MATLAB software used to 2020 is very fast use that. You can use you can see the graphic very speed to know about the problem, use the magnitude voltage and about the passenger. Yeah. Here the result based of the comparison about the graphic LM and NN. So it's the back slide. We can use the result for question, but with the use the ELM or the external learning machine is greater and the value optional the genetic algorithm. Although the difference the value optional in the two the method we can difference is very small, but the computation the speed about the LM is very fast than ANN. For question accuracy and performance testing, for question accuracy use the indicator MAE and MAPE. MAE is a numeric calculation use mean absolute error and MAPE mean absolute percentage error. ELM use the learning machine is 2.02 and 0.76% about the MAPE. But what about the INN? INN just 1.03 use the MAE and the MAPE use the 0.60%. It's very different. The performance testing, in the performance test is verified that the system meet is specific performance efficiency object. The performance testing can be used, measure and report on data and input or output rates. The program execution speed ALM is very speed is a 0.010 seconds, but INN just is 0.500 seconds. About the power flow, yeah. So this is the conclusion we can use. Accuracy, the LM or external learning machine method is successful to use the analysis about the flow of electrical power or load flow, and for accuracy, the prediction of the electric power for analysis carried out by this method MAE and MAPE. The result is 2.02 and 0.76% because the MAPE value is less of 10%. The accuracy of the method electric is good. About the INN is big of the 10%. Yeah. The performance about the ALM is method is able to complete analysis of the flow electric power in a very fast computation. The computation is 0.010 seconds to execute about the power flow, the method. While the INN method is power, just with text 0.500 seconds to complete the analysis. About the analysis is method electric power create use the parameter, namely of the number neurons is just 5, and input and output is it's much as 2, and the number of a hidden layer is much as just 1. Yeah. Okay, I think that is my presentation about the power flow, use the ALM, compare ALM and INN. Thank you. I come back to moderator, please.
Okay, thank you very much for your presentation, sir. Okay, anyone have any questions to Mr. Muhammad Darwis? If you have any questions, just raise your hands or send to our chat room. Okay, if we don't have any questions, so I will ask you, sir.
Yes.
As you said before about your research that you use two methods,
Yes.
namely extreme learning and genetic algorithm. Yes,
Yeah.
right?
Yes.
So I want to ask you, what is difference from these two methods and why you use this method beside the value is very similar?
Yes.
Yeah, please give your explanations.
Okay. About the problem, power flow is the fast to know the problem. I have to immediately to know. For example, line the transmission, you have to know the problem. If you slow to use the problem, is sometimes it's many problem in your area. The using the ALM, it's very speed to know about the problem power flow. Sometimes it's the less file is very small, but the speed is very speed. Use the ALM and use the NN. Sometimes is the training is slow. Many factors about the problem. So is the increasing about the speed very fast. Use the ALM. Thank you, Director.
Okay, thank you very much for your answer, sir. Okay, all right, we will go to the next presenter. We have Mr. Ervanda Siregar here. Okay, please give your presentation, sir. You have 10 minutes.
My voice clearly. Is my voice clearly heard by you people?
Can you repeat, sir, because we can hear you clearly?
Is my voice clearly?
Yes.
Okay. Is my presentation show at you?
Yes, yes.
Okay. Good afternoon, participants of the third ICoGEE conference 2021. Firstly, let me introduce myself. My name is Ervanda Siregar, and currently I work at PLN Unit Induk Wilayah Bangka Belitung. At this time, we will discuss my paper entitled Optimizing the Belitung Solar Power Plant to Reduce Emission of Waste Gas Diesel Power Plant. For your information, the Belitung Solar Plant with installed capacity of 1 megawatt peak operated in 2013, which is assistance from Ministry of Energy and Mineral Resources to accommodate the addition of the new renewable energy mix in the Bangka Belitung province. Over time, because the operating pattern of the solar plant is considered not optimal, we built a diesel plant located next to the solar plant. The purpose of diesel plant construction was respond to the increasing demand for electricity and optimizing the drop voltage in Belinyu sub-district. Besides the hope to improve the reliability of the electricity system, the construction of diesel plant also creates environment problems. The problems here related to exhaust gas resulting from burning fossil fuels to generate electricity. With solar plant optimization, it is hoped that it will reduce the operating hours
Sorry,
of the
sir.
Yeah.
Your slide still in the first.
Yeah.
Okay.
Yeah, memang I've not turned to next slide. Okay, with solar plant optimization, it is hoped that it will reduce the operating hours of diesel plant engine and as well as have a positive impact to the environment. Okay, this presentation has divided for main idea, namely the first electrical condition of system Bangka, the second electrical condition of system Belinyu, the third diesel power plant environment issue, and the fourth, the improvement that we can do. Okay, this slide describes the electrical condition of system Bangka. System Bangka has power ability around 182 megawatt. The peak load is 178 megawatt, and the reserve margin is 4 megawatt. And the table depict generation type, the design capacity, the power ability of each power plant. At the number 8, we can see the design capacity of Belinyu diesel plant is 6 megawatt and power ability is 5.6 megawatt. Okay, this slide describes the electrical condition of system Belinyu. Belinyu sub-district located in the North Bangka, an electrical system has diesel plant and solar plant. Both of our plant located at Bukit Ketok supplies 3 feeders to distribute the electricity to the consumer. Okay, this is the signal diagram describe the interconnection system in middle voltage level between Kelapa substation and Sungalir substation. This forms a system to supply the Belinyu sub-district, which has a diesel plant and solar plant. And as we know, the Belinyu system has 3 feeders to ensure reliability supplies. Okay, this is the environment issue. This is the result of diesel plant waste gas test. This test held at April 2020 and 6 machines have different results. The result describe content of waste gas in 12 hours test. The result divide to 4 main components, namely nitric oxide, sulfur dioxide, particulate, and carbon oxide. From this table, we can say the 4th machine and 5th machine has the worst result of if compared with the other machine of this result. Okay, the improvement that we can do, the first solution, it can be modeling the storage system. As we know, the main problem of solar plant is cannot continuously run supplies energy. It depends on availability of sunlight and not to be able to operate at night. With the storage system, the solar plant expected to supply power at day and night. The second, improve the diesel plant operation scenario. The system modeling is carried out with the aim of finding most efficient operating pattern and supporting the reduction of the number of operating machine. Okay, this is the modeling. The solar plant has 5 group and material that support that plant. It's shown in this slide. It has inverter, the string group, number of solar panel, and power capable according to the plant design. Group A and B can generate approximately 200 kilowatt peak. Group C can generate around 200 watt peak, and group D and E can generate about 180 kilowatt peak. With simple formula, it is expected that each group can supply a minimum of 40 kilowatt. So the power in a day become 1,440 kilowatt hour. This number is obtained by multiplying 40 kilowatt to 24 hours and 1.5 as the safety factor. This column shows the value of power that we need in 3 days if sunlight is not available. Results of the calculation is 24,000 ampere hour each group that we need the battery or storage system. The capacity is 24,000 ampere hour. Okay, this is the modeling result with ETAP 2012.6. The table result depict the operation scenario of electrical system. It shows the supply of Sungalir substation, Kelapa substation, diesel plant, solar power plant, and the total load, and the bus voltage condition is of each scenario. The scenario divided by all source operation, Sungalir substation off, Kelapa substation off, and some machine off, and solar power plant off. From the table, the most efficient scenario is condition when the solar plant supply 200 kilowatt. Okay, and the diesel plant stop to engines, and this scenario can supply maximum load at 7, and the bus voltage at minimum requirement 19.5 kilovolt. Okay, this is the simple equation of carbon footprint. The total design it is 1 megawatt peak. Capacity factor approximately 20%, and watt peak 200 kilowatt peak. Electricity production untuk for annually we can say 6.48 gigawatt hour, and the potential carbon footprint we can determine the value with multiplying electricity production, multiply bubble emission factor, and divided by 10 to the power of minus 3. So the value is 0.0060265 million tons annually. So the conclusion from the change of operating pattern of W diesel power plant, which originally operated 6 engines to 4 engines, it has the potential to reduce exhaust emission. The potential for reducing exhaust emission can refer to the data from the table 1. The recommended engines not to operate are Kamin 4 and Kamin 5, where these 2 engines have the worst test result among all machines. The second, assuming the